Okay, let us discuss 1.154. So this says two identical buggies of 1 and 2 with one man in each move without friction due to inertia along two parallel rails towards each other. So let us say we have two parallel rails. So this is one parallel rail. You have another parallel rail that is basically parallel to the one, and there is a buggy that is moving on this fast. Let us say this is buggy number 1 and this is moving in this direction, and there is a buggy number 2 here. You have both are identical buggies. So let us say this buggy and this buggy are identical. Are you getting? And this is moving in this direction, so let us call this the buggy number 2. Both buggies have a mass m. Inside this there is a man, and there is a man in this inside this buggy also. They are coming to each other, towards each other. So let me read. When the buggies get opposite to each other, the man exchanges their places by jumping in the direction perpendicular to the motion of direction. So let us say after some time situation is something like this. This buggy reaches at this position, and this buggy also reaches at this position. I think you are able to see. At this point of time, what these mans are doing, this man jumps on this buggy and this man jumps on this buggy. So men are jumping, and they jump such that their velocities are perpendicular to this velocity. So this is going in this direction, this is going in this direction, and their jump is basically perpendicular. So they jump perpendicular to this, and this jumps perpendicular to this. So this says man jumps perpendicular to their velocities. So they are jumping perpendicular to their velocities. Now question says, as a consequence, buggy 1 stops and buggy 2 keeps moving in the same direction. So let us say this is buggy number 1. This stops, so V becomes 0 after when the man exchanges. And buggy number 2 keeps moving in the same direction with velocity is equals to V. This start moving in this direction. Let us call this moving with velocity U. So this keeps moving in this direction, velocity U. Or let us say the question says V. So let us keep this V. So this buggy number 2 keeps moving in this direction with velocity V. Now question says find the initial velocities of each buggies with, it is given that the mass of buggy is capital M and mass of the man is small m. So mass of the buggy is capital M. So M is the mass of buggy. Are you getting? And a small m is basically mass of the man. Now let us try to see what is happening. So this is the situation you have. So this buggy is here, and this buggy is here. Of course all buggies are not deforming, same like the previous one. I have made slightly longer. So what is happening? Initially let us say this buggy is moving in this direction with B1, and this buggy is moving in this direction with B2, and this mass. So this mass jumps in this direction and this mass jumps in this direction. So let us try to see these systems. Rail are frictionless, this is frictionless, and man is basically moving in the perpendicular direction to the rail. So rail will not apply any force in the horizontal direction. If this person moving in the perpendicular direction, so the only force this person will apply on the rail in the direction of the velocity. You see what you will do is, if you try to jump, let us say if you try to jump from this to here, what you will try to push this side, and then you can jump here. This means when you are jumping, you will always apply a force on the platform. So let us say this is the platform. You are sitting on this platform, you are standing on this platform. You want to jump from this platform at this position, and perpendicular to the platform. So in that case you apply a force on the platform in this direction and then you will jump in this direction. So you see, the force applied on the platform is always in the direction of velocity. This means if you want to come this side, then you will apply a force in this direction. So on this buggy, the force applied only in this direction. There is no force applied in the horizontal direction. That is in the direction of rail, in the direction of motion. So no horizontal force is applied. This you have to think slightly. No horizontal force is applied. So this means I can say momentum is conserved even for this, even for this. So let us apply work in terms of momentum conservation. So let us do for momentum conservation for 1. So if I do momentum conservation for 1, so this initially it was moving with velocity v1, that is this mass of man and this buggy both are moving with velocity v1. So I can say initial momentum was m plus m into v1. So this is why the initial momentum. Now let us try to see what the change in momentum you have. Now this man is jumping from this buggy. So there is a loss of momentum. So this man is jumping from this side. So this man will have a velocity v1 even after jumping. So this man is jumping. So this man is taking a momentum of m into v1 in this direction. So you see, this is losing a momentum of minus m times v1. Now this buggy gains another man. This man comes here, but this man is coming with velocity v1. So when this man is coming, this man has a velocity in this direction, that is v2. Are you getting or not? And this man also has a velocity in this direction. I am only interested in this direction velocity. This man coming this direction, this has a velocity v1 in this direction. It also has some velocity in this direction. So this man is coming here. So this man basically takes a momentum of m times v1 from this system. When this man goes on to here, this man gives a momentum of m into v2 to this system. But this gives in this direction. I am taking this direction as a positive. So basically this momentum is negative for this system. So this will be minus mv2. And the question says the final momentum of this after the jumping of the man becomes 0. So this is the 0. So let us say what we have. So m into v1 minus m into v2, that is equals to 0. We have equation number 1. Let us try to explain this equation once again. What I am saying is, I am working in terms of what is the momentum that is gained by the trolley 1, buggy 1, and what is the momentum that is lost by buggy 1 from the initial momentum. And that will give you the final momentum. So I have initial momentum is pi. What is the gain in momentum plus what is the loss in momentum, and that will give you P final. That I am applying here. Are you getting? So you see, initial momentum of this is, I am taking this direction as a positive direction. So initially this was moving with m plus m into v1. So this is the initial momentum pi. What is the momentum gain? So you see, this man is coming after jump. This man is coming here, and this man keeps a momentum of mv2. So this man brings a momentum of mv2. So this, when this jumps here, this will give all the momentum to this buggy, that is mv2. But unfortunately this momentum is in this direction. So basically that even is a loss. So I have to put a minus sign. So the gain is been lost because this momentum is in this direction. So it gives some momentum but gives in the backward direction. So this is minus mv2. And what is the loss due to this? So this man is going from this system. So this man has a velocity v1, and after jumping also this will have a velocity v1. So when this man is in the air, it has a velocity v1. So this loses a momentum of mv1. So this is the loss, this is the gain, but unfortunately gain is in the opposite direction. That's why I have to write a negative sign. If I do all this, I will have this. Now I will take some time for discussing the next equation. What you have to do is, you have to write the same kind of equation for buggy 2. That is, you have to write what is the initial momentum, what is the gain in momentum, what is the loss in momentum, what is the final momentum. So this equation you have to fill for buggy 2. I will wait for 1 minute. Okay, I think some of you might have done this one, so let us discuss. Initially, this is moving in this direction with velocity v2, and so momentum it will have initial pi. So you see, I can use the same thing, pi plus delta p gain plus delta p loss, pi plus delta p gain plus delta p loss, that is equals to p final. So I will put these all terms. So you see here, this initially have a momentum of m plus m into v2, and now this is in this direction, so it will be m plus m into v2, but unfortunately this is in this direction, so I have to put a minus sign here. Now let us say this man goes, so this buggy loses a momentum. First, how much loss? So this loses, so this man has a velocity v2. So when this goes in this buggy, so this loses a momentum of minus m into v2. Are you getting? Because this is also in this direction. So this is a loss of momentum. So this is the initial momentum, and this is a loss of momentum of mv2. If you understand negative sign, I can finally put the negative sign here itself. Or let us say you can plug the minus sign in the beginning also. So basically this will be plus. So let us place. So I can write this equation again. Let us try to understand. So this mass has a momentum m plus m into v2 in this direction, and this mass loses a momentum of m plus. So let me put this minus sign in the beginning. That suggests me in this direction I have a negative sign. So this mass has a momentum m plus m into v2. Now it loses a momentum of m into v2. Of course, this is again the v2 is in this direction, so I have to v2 is negative, so I have taken v2 initially. So now this is the loss. What is the gain? Now this mass, so this is the loss, and if this mass comes here, this brings a momentum of mv1 now in this direction, so I will have to take positive. So this will have a momentum of mv1, and the final equation says this block is moving in this direction with velocity v. So now this has a mass m plus m, and this is moving in this direction, so I will have to apply minus v. Let me explain once again. So you see, this is moving with velocity v2 after the jumping, so it will have a momentum, initially it has a momentum of m plus m into v2. Now this person jumps, so this loses a momentum of mv2 because this has a velocity v2 when it's jumping. So this is the initial momentum, this is the loss of momentum. So this is the momentum left after the jumping, and of course this is in this direction, so I have put a negative sign here. Now there is a gain in momentum, this person comes this side. So this brings a momentum of mv1, so I have to add a momentum mv1, and this momentum is in this direction. Now finally it says, question said this system is going in the opposite direction with velocity v, so I have to write m plus m into minus b because this is going in the negative direction. So what will happen? So this mv2 goes, so I will have m into v2 is plus m into v1, and this is equals to minus m into b minus m into b. Now if I do this one, what we have, so I have to basically solve for v. So I can write this equation in terms of, okay, let us put this m plus m into b itself and take minus sign this side. So I will have mv2 minus mv1. So this is my equation number 2. If you see your copy, what is the equation number 1 you have? So you have equation number 1 is somewhere here, mv1 minus mv2. So this equation is mv1 minus mv2 is equals to 0. So if I plug the value of v1, so I can get the value of v2. Question asked to find out the v1 and v2. So let us plug the value of v1. So you will have mv2 minus, this is mv2 m into, and value of v1 is mv2. From here I can find, from value of v1, this will be equals to mv2 by capital M. I think you are able to understand this one. If you plug this value, so this will be in this equation mv2 minus mv1. v1 is mv2 by m is equals to m plus m into b. So you will have m plus m into b. Are you getting? Now if you do for v2, if you take common, this will be m minus m square by m. This is equals to m plus m into v. So from here you will have v2 m square minus m square divided by m. This is equals to m plus m into v. So m plus m goes, so you will have v2 is equals to mv divided by m minus m. So this is the final velocity v2. You can solve for v1. So let us solve for v1 yourself. So if you will solve, it will come mv m minus m. So you check your answer yourself whether you are getting this value or not. So in one case you will have capital M, in another case you have a small m. So in this problem, important point is to consider what is the loss in momentum when the man jumps and what is the gain in momentum when man jumps. Are you getting? So if you consider that, you will get the answer correctly. So you have to think in terms of initial momentum, that is m plus m into v1. What is the loss in momentum, that is mv1. What is the gain in momentum, that is mv2. And you have to consider the proper sign also. You have to be very careful in writing this equation. This equation you have to be very careful in writing. This is the initial momentum. This is the loss in momentum. So left momentum in the negative direction. That's why I have given a negative sign. And this is a gain in momentum, that is in the positive direction. This is the final momentum. But of course this is in the negative direction, that's why I have given a minus sign. So you have to consider the proper sign also in this case. This is a very good problem. You have to do this problem one time yourself, so that without even consulting the solution you can find the answer in this case. So let's discuss the next problem. Are you getting? Another important point we have in this question is the person jumps perpendicular to the rail. That is very, very important. If the person jumps perpendicular to the rail, in that case the person will not apply any force in the horizontal direction. If person makes an angle theta with the rail, in that case person will basically apply a force in the direction of rail. In this case person moves perpendicular to the rail. In this means rail does not apply any force in the horizontal direction. If it moves in angle theta, in that case there will be normal reaction that wheel will apply. So rail will apply and wheel will apply. Between rail and wheel there will be force in this direction. So if the person jumps in this direction, there will be force in this direction, and that normal reaction will have a component in the horizontal direction. Are you getting? That is very important. So if the person jumps with an inclination angle some theta with the rail, so this is the rail direction. In that case, rail will apply a normal reaction in this direction, in direction opposite to the velocity, and this normal reaction will have a component in this direction, that is the horizontal direction. In that case, you cannot apply the momentum conservation in the horizontal direction because this rail is external system and that apply a force in the horizontal direction, because normal reaction will have a component. Same thing happen for other case also.